Let's start with a problem that every backend engineer eventually runs into. You have a request that comes into your system and it fans out. It hits an API gateway, then a couple of services, maybe a database, a cache, a queue, and somewhere along the way it gets slow or it fails. And you're staring at logs from 5 different machines trying to stitch together what actually happened. That stitching problem is the reason OpenTelemetry exists. OpenTelemetry, OTEL for short, is an open standard for describing what your software is doing while it runs. It's not a product you buy. It's a specification and a set of libraries, and the whole point is that everyone agrees on the same shape for the data. You instrument once in a neutral format, and you can send that data anywhere. OTEL actually covers 3 kinds of data: traces, metrics, and logs. And here we'll focus on traces, because that's what tells you the story of a request. Let's zoom in on the core building block, because everything else falls out of it. It's the span. A span represents a single unit of work with a start time and an end time. Each span carries a name, a duration, and a bag of key value pairs called attributes. Things like the HTTP status code, the query text, the user ID, whatever context you want to attach. Every span has an ID, and every span can point to a parent span. Do that all the way down and you get a tree. That tree is called a trace. A trace is the complete story of one request as it moves through your entire system. The part that makes this work across machines is called context propagation. When one service calls another, it passes along the trace ID and the current span ID in the request headers. So even though your request touched 5 different servers, they all contribute spans to one connected trace. There's a collector, a separate process that receives your telemetry, can batch it, filter it, transform it, and forward it on. And there's a wire format, OTLP, the OpenTelemetry protocol, which is the standardized way spans get shipped over the network. Your app produces spans, exports them over OTLP, and something on the other end receives them. And you don't write most of these spans by hand. Instrumentation libraries wrap your HTTP client, your database driver, your LM SDK, and emit spans automatically. You add a few lines at startup, and the traces just start flowing. So here's where Langfuse comes in. Langfuse is an observability platform for LLM applications, and one of the smartest architectural decisions we made is that we didn't invent a proprietary format. We speak OpenTelemetry natively. Langfuse exposes an OTLP endpoint, and it turns out that an LM call is just in a span. It has a start and an end. It has attributes, the model name, the prompt, the completion, the token counts, the cost, the temperature. A whole RAG pipeline is just a trace. A span for the question, a child span for the embedding lookup, another for the vector search, another for the LM call. LM observability isn't a different problem from distributed tracing. It's a special case of it. For you as a developer, the practical payoff is that you get to use tools you already know. If your backend already speaks OpenTelemetry, your LM traces live in the same world as the rest of your system. You're not maintaining 2 parallel observability stacks. In the classic era, observability was about debugging deterministic systems. In the GenAI era, LMs are non-deterministic. The failure modes are semantic, not mechanical. You need to see the actual prompt, the actual completion, the retrieved context, the token cost, and you need to be able to attach evaluations and scores to that data. Was this answer correct? Was it grounded? Was it safe? OpenTelemetry gives us the skeleton for all of this. OpenTelemetry started as a way to make distributed systems legible. LM applications are distributed systems with a new kind of unpredictable component bolted into the middle. So rather than inventing observability for AI, the right move, and the move Langfuse made, is to extend the standard that already works, meet developers where they already are, and build the AI-specific intelligence on top of an open, vendor-neutral foundation.